This is a PowerPoint that's going to try to find you a way to memorize your polyatomic ions, which I call the orange and blue polyatomic ions. This is the list of ions, and technically this is only half of the list of ions, but this is the list of the eighths and the ites that are just what I'm going to eventually call the bus and the bus loop. So you can see it's kind of an unusual list to have to memorize these random letters and numbers. So what I've devised is for a way to use the periodic table to help you remember that. For starters, when you are trying to memorize them, I have them divided into either the orange or the blue ions. So let's first talk about which ones are the orange ones. The orange ones are this area right here, which I will be in the future referring to as the bus. The way I find them is by looking at the elements right here. That's a P and that's an S, that's phosphorus and sulfur, and it is part of a mnemonic device for, I say, public school bus. So this rectangular area, which after I colored in orange kind of resembles a bus, have something in common when we get to the list of polyatomics. The other section of the periodic table that we're going to concentrate on right now, I call the bus loop. That's this area right here adjacent to the bus, and so that's why it's the bus loop. And then this other area is what I refer to as the annex. And we skip the oxygen, so then we see if this were a bus in a loop, that wouldn't be great because you'd have to run out there in the rain to get your bus. So the bus and the loop are these areas on the periodic table. So here they are, and there's another section over here that we're going to eventually talk about, but right now we're referring to just the bus and the loop, and then there's some extra things that the bus loop does that we'll talk about also in another video. So if you look at just the bus and the loop, you will notice that if you look closely, there is something similar about the ones that are orange and about the ones that are blue. So let's look at the orange ones first. You'll notice every one of the orange ones has an O4 with the element. So it's phosphorus and then 4 oxygens. And the name of it is the name of the element, like phosphorus is just the phos part. And then when it has 4 oxygens, well, all of this entire chart has the ending 8. All of the orange ones have 4 oxygens when they say 8. Now, if you look carefully at the blue ones, all of the blue ones say, for example, this one here is ATO3. Now, we haven't talked about the charges yet, but we'll get to those in just a second. And all of the blue ones have 3 oxygens when they say 8. So the blue ones all have 3 oxygens when they say 8, and the orange ones all have 4 oxygens when they say 8. So once again, to reiterate, the sections of the periodic table, I find them by looking for the P and the S. Everybody in this section is orange. What does that mean? It means when they say 8, they're O4 when they say 8. How do I find the other section of the periodic table? Well, I know there's a bus loop, and I know there's an annex. What's the same about all of those? Well, each one of those are O3 when they say 8. What about those when they say ite. We haven't talked about that yet. But this whole section can also be the element with the ending ite. So if I am PO4, like I'm listed here, and has a -3 charge, I am phosphate. But if I lose one of those oxygens and I'm just PO3, still with the -3 charge, then I'm phosphite, and my ending is ITE. The way I remember that is the larger amount of oxygens is 8. Because I ate, I have a larger number. Because I ate, I'm larger. The other way I remember it is kind of a reference with the Spanish language. This is kind of like ITO, which in Spanish refers to the little version of a person like Miguelito or Teresita. You would be the smaller version if you are the Ito version. So this is kind of like that with an IT. It isn't an O, but it's just the mnemonic tool that I use to remember that. Likewise, everybody on this chart that was blue, that had O3 for 8, has one less still, O2, when it is ite. So to be the ite version, whether you are the orange or the blue, you are one less. The difference with the orange and the blue is how many oxygens they had to start with. So here is my bus and my loop. Everybody in this section right here, if I was going to say what they were individually, I've got a P. So PO4, and now we'll start talking about the charges, has a -3 charge. Well, we already learned the charges when we learned just the elements themselves. And we learned them in the following fashion. There is a zigzaggedy line that goes here between these elements that technically separate the metals, this is the metal side of the periodic table, and the nonmetals. And we use that line to separate the ones that had positive charges and the ones that had negative charges. Okay? So, when we look at that, we have a minus. These guys don't bond, so readily. There are some exceptions. So, we just don't even worry about those. And we say these are 1 away, that's a -1. This column is 2 away. They have a -2 charge. This column was 3 away when they were by themselves. And this column we didn't do yet, and we will eventually. And then the other ones were plus signs, but we're only talking about the negative ones right now. So this charge right here of everybody when they were by themselves was a -1. So if I was just the element fluorine and I became fluoride, I'd be a -1. When I have oxygens with me, when I have any number of oxygens with me, I am either fluor 8, because remember those are blue and the 3 are blue, I have a -1. And when I am fluorite, I'm also a -1. So you'll notice here that no matter what, my charge on everybody that is on the bus loop is the same no matter what kind of ion I am. That's also true of everybody on the bus. So this was the -2 column, if you remember from just a second ago, and that was the -3 column, and those charges are the same whether they're by themselves or whether they're polyatomic, which is what it means when they have the oxygen with them. They have multiple elements. So this section is the only exception to that rule. So I'll trace back your loop, and here is your bus. So this section and this section and this are all the same except this annex up here. Now you'll notice this O for oxygen. You notice the O here for oxygen. I use it as a memory tool to remember that when these are polyatomic, there's an exception. They're the annex. And it goes -1, -2, -3 on their charges, which to me is like a number line. So I remember that that's not an O and now, it's a 0 for the number line. And then when I am NO3, I'm -1. And I'm NO2, I'm -1. When I am in the next column, I am a -2, and when I'm in the following one, I am a -3. So that's the only ones that we're doing right this moment that have an exception to their charges. So I've got my bus and my loop, and I remember that the charges on everything on the bus loop is a -1. These guys are a -2. These guys are a -3. And then I remember that this is O for 0, and the charges here are -1, -2, -3. I do have a way to remember that the orange ones are O4 because they're orange. And I say, how long are you here at West Orange? You're here for 4 years. So the orange ones are O4 when they're the top of the line 8. And then, of course, when they're one less, they're O3 for my 8. And the blue ones, our school color is not blue. So since it's not blue, then those that are blue on here are starting out O3, which is a little bit less impressive than the West Orange O4. And then when they're one down, they're O2. So that's how I remember my polyatomic oxyions.